Good afternoon. I am Dr. Tamrakar from Bharati College of Engineering and Technology. I am teaching food machinery in BE 5th semester. Today we will solve one numerical on jet propulsion. A small ship is fitted with jet of total area 0.65 meters square. The velocity through the jet is 9 meters per second and speed of ship is 18 km per hour in seawater. The efficiencies of the engine and pump are 85% and 65% respectively. If the water is taken amidship, determine the propelling force and the overall efficiency, assuming the pipe losses to be 10% of the kinetic energy of the jet. Here, main point is given, this ship is amidship, so we have to do accordingly. So, in this question, the area of jet is given, area of jet is given 0.65 meters square, 65 meters square. Velocity through the jet relative to ship VR, that is 9 meter per second, and speed of ship. Here in this question, the data given are the total area of jet 0.65 meter square, the velocity through the jet relative to a ship is 9 meter per second, and speed of ship is equal to U is 18 kilometers per hour. Converting this, that is 18 into 1000 meters is kilometers by hour, that is 60 into 60 meter per second. Because we want the speed U in meter per second, so this comes 5 meter per second. Efficiency of engine, it has been given 85%, that is 0.85, and efficiency of pump has been given 65%, that is 0.65, Pipe losses HF, that is friction losses, is 10% of kinetic energy of the jet. So this is 10 by 100. This is 10 by 100, 10% into VR square by 2G, VR square by 2G, that is VR square by 20 into G. Now, as we know, V are equal to U plus V. Here V is absolute velocity of the jet, so this is 9 equal to 5 plus V. So V equal to 4 meter per second. Now propelling force F is equal to rho A V plus U into V. Putting the values here, rho is 1000 for water, area is 0.65, V is 4, U is 5, and this is again 4. So this propelling force is 23,400 Newton. 23,400 Newton. This is the propelling force. Now work done. This is F into U. Now putting the values here, that is value of F is 23,400 into value of U is given 5 meter per second. So this work done is 1,17,000 Newton meter per second. 1,17,000 Newton meter per second is the work done. Weight of water issuing from jet per second. Weight of water issuing from jet per second. Weight of water issuing per second is equal to G into mass of water per second. Mass of water per second, that is, the value of G is 9.81 into mass of water striking per second is rho A V R. Putting the values 9.81 into rho is 1000, area is 0.065, and VR is given 9 meter per second. So here this value comes 57,388.5 Newton per second. The pump should have the output which will give jet a relative velocity VR and also overcome the pipe losses. Pipe losses are the friction losses, so we have to consider all these. So the output of pump per unit weight of water, output of pump should be more than the effective use to overcome the pipe losses. So output of the pump per unit weight of water per unit weight of water this is equal to kinetic energy that is required of jet plus pipe losses. So this is V R square by 2G is the kinetic energy plus the pipe losses is VR square by 20 into G. So this is V R square by 2G and in bracket common, taking common 1 plus 0.1 plus 0.1. So this comes by putting the value here. Input to the pump per unit of water, input to the pump per unit of water equal to output by efficiency equal to output by efficiency. As we know, efficiency equal to output by input. Now putting the values is 1.1 VR square by 2G and this efficiency given 0.65. Now the input of the to the pump is equal to the output of the engine. Okay. Now hence input of to the engine per unit weight of water, input to the engine this is input to the pump and this is input to the engine. Per unit weight of water is equal to 1.1 VR square by 2G into 0.65 into 0.85. So here putting the value of VR equal to 9, that is 1.1 into 9 square by 2 into 9.81 into 0.65, this is 0.65 into 0.85. So here this value comes 8.22 Newton per Newton. 8.22 Newton meter per Newton. Now, so the total input to engine, equal to weight of water into input per unit weight of water per unit weight of water. Okay, now this is 57,300 388.5 into 8.22. So this comes 4,71,733.5. 763.5 Newton meter. Now overall efficiency eta overall equal to work done by jet that is divided by total input to engine. That is equal to 117,000 by 4717 4717.5. So this overall efficiency comes 1248. This is 24.8% is the efficiency of this type of machine. Now taking one more numerical, a jet propelled boat moving with a velocity of 5 meters per second draws water amidship, means at the 90 degree. The water is discharged through two jets provided at the back of the ship. The diameter of each jet is 150 mm and the total resistance offered to the motion of boat is 4905 Newton, that is equal to 500 into 9.81 Newton. Determine volume of water drawn by pump per second and efficiency of the jet propulsion. Now we have to solve this question. Here velocity of boat is given 5 meters per second. Velocity of boat is always taken as u. Diameter of each jet d is given 150 mm. That is equal to 0.15 meter. So the area of jet equal to pi by 4 a square and the number of jet are 2, so the total area is equal to 0.03534 meter square. Total resistance to motion is 4905 Newton. And the propelling force must be equal to the resistance of the motion, because this F equal to F propelling force, that must be equal to 4905. There should be more than this resistance force. So we have to find this equation for this propelling force is rho F equal to rho A plus U into V, and value is given. This are 500 into 9.81. In both the terms it has been given, so better we use this 500 into 9.81 equal to the value of rho is 1000, and the area is 0.03534 into V plus U is given 5 into V. So solving this equation, we got a quadratic equation as 3.6 V square plus 18 V minus 500 equal to 0. This is equal to 0. By solving this quadratic equation, we have got two values of V in positive and negative. So we take the positive, and the value of V comes 34.37 meter per second, ignoring the negative one. Now the volume of water drawn per second is equal to the water discharged through orifice. Volume of water we have to find out. So here this is volume is A into VR. This is volume. Volume equal to A into VR, and area is, we have calculated, 0.03534 into VR is A into, that is VR is V plus U. V plus U. Putting the values of V plus U here, 0.03534 into the value of V is 34.37, and U is given 5. So here the volume comes 1.39 meter cube per second. 1.39 meter cube per second. And now we have to calculate the efficiency of the jet propulsion. Efficiency of the jet propulsion is given eta equal to 2 VU is divided by V plus U square. V plus U square. Putting the values here, 2 into V 34.37 into U is 5. This is divided by 34. This is 34.37 plus 5 square. So the value of eta is here 0.2217, that is equal to 22.17%. And you have to solve similar type of questions what have been asked in the university exam paper. Thank you.